Welcome all for the today's session. We continue with our biostatistics module, and today's session is about the shapes of the distribution. Okay, so up till now we have talked about the data, the graphical presentation of the data. Now here today, the most important thing we are going to talk about the shape of the distribution, how the data is distributed, and what is the shape of the distribution. Okay, so here basically the data may be uniformly distributed. That means there is no much variation among the data. Here the frequencies are almost equal across the values. It will have a flat appearance. So no value occurs more commonly. Most of the values are almost similar in nature. And this will look like this. Okay, there is no variation. They are almost similar. Okay. So this is not very frequently asked, but the most frequently asked is a normal distribution. Always there are questions about the normal distribution. Okay. So in normal distribution, the feature is that it is bell-shaped, symmetrical. Most observations are near the center, and there are important characteristics that mean is equal to the median and it is equal to the mode. Okay, and it is symmetrical around the mean. Okay, example is IQ, height, birth weight. The characteristics of the normal distribution you should know. These characteristics are the bell-shaped, it is symmetrical, then most observations are near the center. Here mean is equal to median is equal to mode, and it is symmetrical around the mean. Okay, so this is what is the normal distribution. Okay, the most commonly they ask about this mean plus minus 1 SD. Okay, this is the one standard deviation around the mean. Okay, this is the mean. Okay, then this is the standard deviation plus 1 standard deviation. This is minus 1 standard deviation. Okay, so the question most of the time they ask what percentages of the observations lie between plus minus 1 standard deviation. Okay, so between plus minus 1 standard deviation, 68.26% of the observations will lie. Okay, then you have plus minus 2 SD will cover 95% of the observation. Okay, 95% of the observations will be between the plus and minus 2. Okay, so this is the mean, this is the plus 2 SD, this is the minus 2 SD. So between these, the 95% of your observations will lie, and only 5% will be outside. That means 2.5% on this side and 2.5% on this side. I hope you understand this. Okay, so this is the mean. Here it will be 50%, here it will be 50% observations, but between plus 1 and plus 2, 68% observations will lie. Between plus 1, plus 2 and minus 2 standard deviation, 95% will lie. And between uh, third standard, 3 SD plus minus 3 SD, 99.7% data will lie. Okay, so these all three you should know. Between plus minus 1 SD, how much percentage of data? Between plus minus 2 SD, how much percentage of the data? Between plus minus 3 SD, how much percentage of the data is lying? Okay, that you should know. Roughly remember 68, 95, and 99. 68, 95, and 99. These three figures you should know. Okay, so symmetrical distribution, right half will mirror the left half. The typical of normal distribution. This is what is the typical of normal distribution. Sometimes there may be asymmetrical distribution, that is the skewed distribution. Now we will talk about the skewed distribution. Okay, so symmetry is one feature. So in normal distribution there will be symmetrical distribution, right half will mirror the left half. But if there is a skewed distribution, then you will find asymmetrical distribution. Now the data may be positively skewed or the data may be negatively skewed. Okay, negatively skewed means there are certain observations on one particular side. Okay, on this side, if they are there, then that is a negatively skewed. Okay, so positively skewed distribution when the tail extends to the right. So if the tail is extending to the right and not much on this side, that means it is a positively skewed data. Remember, it is the direction of the tail that determines the skewedness. Okay, if the tail extends to the right, it is a positively skewed. Most values are clustered at lower end. Okay, so example is income, hospital stay duration, etc. Okay, so here you should remember the relationship between the mean, mode, and median. Okay, here mean is always more than the median, and median is always more than the mode. What we have seen in the normal distribution, mean is same as median, and median is same as mode in normal distribution. But when you have the positively skewed distribution, positively skewed means your graph is like this. Okay, graph is like this. Okay, so that is what is the positively skewed distribution. Okay, so tail extends to the right here. Okay, and here mean is more than the median and median is more than the mode. These relationship also you should remember, because these are the SBA questions. In the relationship in the positively skewed distribution is mean, they will give you the different values over here: mean more than median, less than mode, mode less than median, or whatever it is. Okay, so you should remember what is the correct here. Mean is more than the median and median is more than the mode. Okay, so if with the figure, if you remember, you will be understanding it in a better way. Okay, so this is the positively, the tail is extending to the right. Okay, so here it is the mean which is the higher than the median, and median is higher than the mode. Okay, so mode is less than the median, median is less than the mean. So this is the figure which you should remember, and the relationship you should remember in a positively skewed data. Okay, here the tail is extending to the right. Okay, that is what is the positively skewed data. This is the negatively skewed data. Okay, here you will find the tail is going towards the left. Okay, this is the positively skewed data. Okay, this is the right skewed distribution, this is the left skewed distribution. Okay, now we will talk about the negatively skewed distribution. Here the tail extends to the left. Okay, so the tail extends to the left. Most values are clustered at higher end. Most of the values are clustered at the higher end. So here what is the relationship? Mode is more than the median, and mode is more than the median, median is more than the mean. Okay, so if you see here, this is the negatively, here the mode is more, here there are the less and less values. Okay, so mode is more than the median and the median is more than the mean. Okay, so that is what is the difference between the relationship of the mean, mode, and median in the normal distribution, in the positively skewed distribution, or in the negatively skewed distribution. Okay, here in the negatively skewed distribution, mode is greater than the median, median is greater than the mean. Okay, now regarding the this shape, you should know something called as kurtosis. Kurtosis describes the pickedness or the flatness of the curve. Okay, how big the curve is or how flat the curve is, that is called as kurtosis. Okay, there are three types of kurtosis. You may have a platykurtic, that means the curve is flat. You may have mesokurtic, that means normal bell curve. You may have a leptokurtic, that is a peak curve. So you may have the curve like this. Okay, like this. So that is the peaked curve. Okay, that is the leptokurtic. So this is what is the kurtosis image. So you see the flat curve. This is the platykurtic. This is the normal distribution. Okay, bell-shaped curve. This is the mesokurtic. But sometimes you may have a tall peak in the middle. That is the leptokurtic. Okay, so that finishes the today's topic of the shapes of the distribution. So I'll just revise. In the positively skewed distribution, you have mean is more than the median and median is more than the mode. Okay, here this. Okay, mean is more than the median and median is more than the mode. While in negatively skewed distribution, mean is smaller than the median and median is smaller than the mode. Okay, so that is negatively skewed. So we have few questions, doctor. Who wants to read questions? Dr. Monica, you want to start?
Sir.
Yeah.
Yes, sir.
Let Dr. Monica start. Yeah, sorry.
Yeah.
Yeah, please.
Question number 1. Which statement regarding normal distribution curve is correct? A. Median is greater than median. Mean is greater than median. B. Median is greater than mode. C. Mean is equal to median is equal to mode. D, mode is greater than mean, and E is distribution is always skewed. So answer is C, mean is equal to median is equal to mode.
Correct. Normal distribution, all three are same. Mean, mode, median, all are same. So in a perfectly normal distribution, the curve is symmetrical. Mean, median, and mode are equal. All lie at the center of the distribution. Okay, next.
Question number 2. A data set of hospital stay duration has a long tail towards the higher values. Which statement is most likely correct? A, median is smaller than mean is smaller than median is smaller than mode. B, mean is equal to median is equal to mode. C, mean is more than median is more than mode. D, mode is more than mean is more than median. And E, median is more than mean is more than mode. So this is tail is towards the higher value. This is the left skew. So mean is less.
Is it left skewed or the right skewed? State duration has a long tail towards the higher values. Higher values, now this is the graph. Higher value will be towards here, no? So it will be right skewed, no? So right, so you will have the mean more than the median, more than the mode. Okay.
So C.
Okay. C. So in a positive, so this is a positively skewed distribution. Tail extends to the right. Large values pull the mean to the right. Okay. So relationship will be mode is less than median and median is less than the mean. Okay. So
Yes,
remember, positively skewed, mean is the largest. Negatively skewed, mode is the largest. Then you just remember then median and mean relationship. Okay, you got it?
Yes.
Next.
Question number 3. Which relationship between the mean, median, and mode is seen in negatively skewed distribution? Option A, mean is more than median is more than mode. B, mean is equal to median is equal to mode. C, mean is less than median is less than mode. D, mode is less than median is less than mean. E, mean is equal to mode less than median. Sir, answer is mean is less than median is less than mode. So answer is C.
C. Mode is going to be the largest here. Okay. So that one, if you remember, then rest of the things definitely you will be able to work out. Okay. So mean is less than the median and median is less than mode. In a negatively skewed distribution, tail extends to the left. Low values pull the median to the left. Therefore, mean is less than median, less than mode. Next.
Question number 4. A graph shows frequencies that are almost equal across all values. What is this type of distribution called? A, positively skewed. B, negatively skewed. C, normal. D, uniform. E, bimodal. Sir, this is normal distribution.
Frequencies are almost equal across all values. So there is no variation at all here. So it is going to be uniform distribution. Okay, there is no variation. So it is going to be uniform. So uniform distribution, all values occur with similar frequency. Graph appears either rectangular or flat. No clear central peak will be there. Okay. Next.
Question number 5. In a normal distribution, approximately what percentage of observation lies within plus minus 1 standard deviation from the mean? A is 50%, B 68%, C 75%, D 95%, and E is 99.7%. So plus 1 standard deviation is 68%. Option B.
Yeah, option B. So here plus minus 1 SD 68%, plus minus 2 SD 95%, plus minus 3 SD 99.7%. Here sometimes they modify this particular question to talk about only plus 1 SD, or sometimes talk about minus 1 SD. Okay, or sometimes talk about plus 2 SD. Sometimes they talk about only minus 2 SD. Okay, and then they ask you the how much percentage they will lie, then it will become a, if it is a plus 1 SD only, then it will become 34%. You got it?
Yes, sir.
Okay,
Half of the.
half of that. They may give some scenario like cholesterol values, then they will give the standard mean and the standard deviation. Okay, and they will frame a question so that they will ask only about plus one SD. Next, sorry, Dr. Sansi, you want to go ahead with few questions?
Yes, sir. A normally distributed variable has mean is equals to 100. Standard deviation is 10. Approximately 95% of observation lies between. Standard deviation is 10. 95%. Okay. 80 to 120, sir.
Yes, 80 to 120. Okay, so here such type of calculation you have to do, not very difficult. Okay, 2 SD you will go on either side. Okay,
Right. Yes.
so 95% values lie within plus minus 2 SDs. So 100 plus minus 2 into 10. Okay, next question.
In a normal distribution, approximately what percentage of observation lies within plus or 3 standard deviation from the mean? 68%, 90%, 95%, 97%, 99.97%. Sir, option E, 99.7%.
Yes, plus minus 3 is 99.7%. So empirical rule, plus minus 1 SD is 68%, plus minus 2 SD is 95%, plus minus 3 SD is 99.7%. Almost all observations lie within plus minus 3 SD. Next.
Birth weights are approximately distributed with mean of 3 kg. Standard deviation of 0.5 kg. Approximately 68% babies will have birth weights between. Okay. And 5 into 1. So 2.5 to 3.5, option C, sir.
Yes, you got how to calculate now. Okay, 68% values will lie within plus minus 1 SD. So 3 plus minus 0.5. Okay, next.
An income distribution graph shows most observation clustered at lower values. Okay, very few high values, long tail towards the right. Okay, what type of distribution is this? Uniform, normal, negatively skewed, positively skewed. Sir, option D, positively skewed.
Why positively skewed?
This towards the higher values.
Yeah, long tail is towards the right. Okay, so it is a positively skewed. The direction of skewness is named according to the tail. Okay, not where the most observations are clustered. So right-sided tail, it is a positive skew. Okay, common examples are income, hospital stay duration, waiting times, etc. Why it is called positively skewed? Because most observations are at lower values on the left side, but very large values will stretch the tail towards the right. Therefore, it is right skewed or a positively skewed. Okay. Example is the income distribution. Most people earn moderate income, but few will earn extremely high income. Okay. So example, suppose here these are the values which are given. Most of the values you see here, but there is only one value 120. So that is pulling the tail towards 120. Okay. So it is a positively skewed. Okay. Most values cluster on the left, but there is only one high value which will pull the tail to the right. So tail has gone to the right. So distribution becomes positively skewed. So again, the relationship mean is pulled towards the extreme high. So mode is less than the median and median is less than the mean. Okay. So mean become the highest here. Okay. So this is what is the normal distribution. This is what is the left skewed distribution. Here mode will be higher. Okay. And the right skewed, median will be higher. Okay. Next. Sorry. Yes.
Which
Next.
feature is characteristic of a normal distribution? Asymmetrical curve, mean affected minimally by extreme values. Curve is bell-shaped and symmetrical. Presence of right-sided tail and mode is absent. Sir, option is C. Curve is bell-shaped and symmetrical.
Correct. Curve is a bell-shaped and symmetrical. Normal distribution, bell-shaped, symmetrical, mean is equal to median is equal to mode, equal tails on both sides. Next.
A researcher compares the shape of three frequency distribution curves. One curve has very sharp central peak, most observation clustered near the mean. Okay, heavy tails clustered near the what type of kurtosis does this represent? Very sharp central, okay, plateau, meso, lepto, positively skewed, uniform distribution. Sir, lepto kurtosis.
Yes, because it is a tall peak in the center. Okay, C is leptokurtic. Leptokurtic distribution, tall and sharply picked, heavy tails, greater concentration of values around mean, and more extreme values or outliers possible. Next.
Which statement regarding a platykurtic distribution is correct? It has very sharp peak. It has heavier tails than normal distribution. It is identical to normal distribution. It is flatter and broader than normal distribution. Mean is always greater than median. So option D, it is flatter and broader than normal distribution.
Yeah, platykurtic is a flatter one. Okay, so it is flatter and broader than the normal distribution. Platykurtic distribution, flat and wide curve, lower central peak, fewer extreme values, more spread out the data. Okay, leptokurtic is a sharply peak. Mesokurtic is normal distribution. Platykurtic is a flatter curve. Okay, this is just to summarize. Normal distribution shape is a bell-shaped, symmetrical bell-shaped. There is no skewness, and mean is equal to median is equal to mode. Then you have a positively skewed where the tail is to the right, tail direction is to the right, and here mean is more than the median and median is more than the mode. Negative skewed, here the tail is to the left, the tail direction is on the left, and mean is less than the median, median is less than the mode. Then you have the uniform distribution where the shape is flat or rectangular. There is no tail as such, and even there is no peak as such. Okay, then uniform frequencies are nearly equal. Okay, then regarding the kurtosis, leptokurtic will have tall narrow peak, heavy tails, and outliers are possible. Mesokurtic, normal bell-shaped curve, normal kurtosis. Platykurtic, it is a flat broad curve, it is less peaked. Okay, there are certain things which you should know about normal distribution rule. Plus minus 1 SD is 68%, mean plus minus 2 SD is 95%, and mean plus minus 3 SD is 99.7%. So that finishes the today's topic. Thank you.